Hi. Today we're going to talk about an important principle in object-oriented programming, the idea of inheritance. So let's review a little bit and then get into it. So far when we've been building up our classes, we can incorporate other classes inside the class that we're making. For example, we could have a string name in a person class. And in our last homework, we made a dynamic array that had a Java array object. And they could use the capabilities of those types in the class. You can find out how long a string name is. You can access the characters in it. Same with the Java array. You can store values in it and pull them out and so on. And that's a very common and useful approach. And this idea of building up one class using the functionality of other classes is an idea called composition. And it's a super standard way of making your class be more powerful. You don't have to replicate you don't have to make your own like fake string inside your class. You just use the power of something that already exists, right? And so again, a lot of programming is building on things that are already existing, or slowly yourself adding more and more classes to get to some final class that does exactly what you want. And in fact, in object-oriented programming, there's often four main principles. I showed five here. Four main principles that we talk about, and those are the ideas of abstraction, encapsulation, and then inheritance, which we're talking about today. And then later this week we'll talk about polymorphism. Now I want you to just review the abstraction, for example. When we, for the homework again, made this dynamic array class, that is a great example of both abstraction and encapsulation. The abstraction is that, for example, the dynamic array 2 class had a very complicated internal mechanism of having a larger amount of data that it stored and doubling every once in a while and copying stuff. And, we really, using that class, while it was great for us to just add stuff to the end, we really had no interest in how that happened. We don't want to know all the complications there. So that's abstraction, right? You have a nice interface, and you just say add to the end, and it does it for you. The encapsulation was that there's these protected or private instance variables, and the only way to access them were through the mechanisms like add or get and set. And that allowed us, again, to change in the dynamic array to dynamic array 2 the internal structure, and other code using that wouldn't have to change, right? So there's still set, get, add for both those classes, but one was a lot faster than the other. And by doing this process of hiding the internal data, we were able to make that change invisible to the outside world. Okay, inheritance is a way of showing relationships between classes. And it's basically when one class is defined in terms of another. So while composition describes has a relationship, so a person has a string name. Inheritance is when there is you're saying one thing is a kind, something, or a kind of something relationship. So for example, a child is a human. You don't say a child has a human or a human has a child, unless it doesn't make sense to say it possesses that as part of it, right? It is a relationship between the two. It's a kind of this thing. So a child is a kind of human. And if we're writing classes to describe both a human and a child, somehow we need a different mechanism than composition, which says this has this, possesses this inside it. So some other examples of this, so composition, a car has an engine. If you had a car class, you could imagine it having an engine type instance variable inside it. A form, like on something to fill out, has a name field, so you fill out something and you have to type in your first name and last name and so on. A zombie model in a game might have a texture, something that shows how the details get drawn. But for inheritance, you can say like a car is a vehicle, is a kind of vehicle. A form, again, is some kind of user interface widget. And a zombie is a kind of monster or a kind of enemy or something like that, right? So again, those are different relationships, and somehow up to this point we haven't really known how to describe those relationships in code, even though they're very, obviously very powerful. You know what they mean when I say it out loud. So in inheritance, you basically just define one class in terms of another. And there's a bunch of different names for this in so different languages, but you say a subclass, like a child, is defined in terms of the superclass, the human. These names are also called, sometimes they're parent-child. So a zombie child is a child of a monster parent class. A zombie derived class is derived from a monster base class. And again, these terms, it's not clear to me why there's so many different terms for this. And I'd say in Java, this sort of subclass superclass is sort of the preferred description. For example, in C++, I think it's more this base derived parent-child kind of stuff shows up a little bit more. Now the thing is, the subclass basically gets the functionality of the superclass and then can specialize it in some way to make it more appropriate for that specific, more detailed subclass. All right, so let's make a base, what we're going to tend to be a base class, a person. So over here, let's just kind of think it through. I have person. We're going to have some instance variables, right? So I make a private string. Here comes our name. Oops. And let's just add in one more here, private int age or something like that, right? Well, let's just leave it. Otherwise, I have to start, filling in age everywhere we go, kind of thing. Okay, so we have our instance variables, and then we need a constructor. So that's a public person constructor. And since there's this name to initialize, I'm going to pass in a name here. And I'm using this little underscore notation to show that this is like something kind of coming in and sort of temporary. It's just a convention that some people like to use. And I am assigning to the instance variable. I do like how it highlights where that instance variable comes from when you're there. I'm going to assign it this parameter that comes in here. So I'm going to pass in a person with David and assign it to the instance variable and so on. Now let's say we want to be able to change our name. Sure, why not? So this is kind of a setter. Why use change name instead of set name? I think sometimes, you don't always want to have just like set get for each instance variable. It provides too much access to those internal values. But in this case, there's an operation I want to have happen, and I want to be able to change a name, right? So sometimes it's better to have the descriptive methods that still use or change the internal values, but they perform something that people want to do to a person. And here I want to change a name. So I have a new name, and I am just assigning to name new name. Oh boy. And let's, we can make one of these things now. Person me equals a person David. And I got to do a new person. Okay. I think with object-oriented programming, there's a lot more little bits to remember in the syntax. And we should test this. So if I print out me, and if I run it, I get that reference, right? This is the package, this is the class, and this is some kind of reference. So to be more meaningful, I should print out a toString. I should have a toString. And again, this is a standard method that a lot of things look for of how an object describes itself in text. And we have to make and return some kind of string that then gets used from the print line among other methods. So I'm just going to make kind of a basic thing here. And when I run it now, okay, that is just annoying to me. Okay, there. Name David. Okay, so this is a sort of a generic-y kind of thing. Not generic in the sense that we've been learning generics, you're right, but this is a um, a pretty basic definition of what like a person is, right? It just has a name. It doesn't really say, it's not really doing much for us, right? Okay, so I can make another class based on this person class using the Java extends keyword. So when I define a class, I would say public class student extends person. And basically, it gets all the instance variable and methods from person with some caveats here. So let's make another class in my package here. So here's Lec28. We have person. I'm going to add in a new class. I'm going to call this student. And sure, I want that. Okay, good enough. Now the thing is, I want to show that this thing is related to the person class. So I'm going to say, hey, I'm not making this from the beginning. I'm not going to have like a string name in here. I'm not going to replicate that code and redo it all in here. Instead, I'm going to say, let's use person as a starting point and build on it. All right, so extends person. And let's shrink this back a little bit. We don't really need that at all anymore. Let's get rid of this line that I get so annoyed with. Here it's saying, okay, if I'm building this, I have to know how to build this. And the problem is it uses this person thing, and so there's some issues here. So let's try to see why there's an issue. Student u, sure, why not, equals new student. There's not enough here to know how to build a person. So a person has one constructor. It's a constructor that takes in a string name. Normally a class gets a default constructor until you define your own constructor, and the default constructor zero initializes all the instance variables. This would be like the null, I guess. But in this case, I made a constructor, and the default constructor goes away. And what this means here is that it doesn't really know how to do this. It's saying here, it's undefined for default constructor. We must make a constructor. All right. So let's talk about also, what is student going to add to person? There's more to it than just the name, right? So what does a student have as well? Well, they have a tuition bill, as far as I can tell, right? So we need to, in the constructor, set up this tuition bill, but also a student has a name because it extends person. So let's make our constructor public. Let me just make sure I go to my slide notes here and make sure I'm on the right track here. Okay. So we need a student constructor, and in here we want to somehow build up the person part and our new part, which is a tuition bill. So there's going to be a string student name, and there's going to be an int the bill amount. Okay, so in here, I know how to initialize the tuition bill. I assign bill to it, right? So it's happy enough with that. Now the question is, how do I get to this name that's in person? It's private. Even though I get these instance variables, in other words, I have storage for them, I don't have the right to just go and access it directly. So we need to construct the person part of student in the student class. Oops. So there's some special notation for that. For example, I can't say like this dot name. It doesn't know about it, right? That is private. And I can't really if I just call like a person constructor here, it doesn't know what to do with it. So there's this special notation again, and you say super, and that means, hey, I know I inherit from something, and I'm the subclass, and the thing I inherit from is the superclass, and whatever that super thing is, in this case, Java can figure out that the super class is person, call its constructor and use it to build up the person part of the student. So I'm going to pass along the student name here, and this part here again makes the person part of the inherited class, and then this thing adds in the added part. So when you make a new student object, it contains the instance variables, the data members of person. In other words, that thing on the heap where you build it has space to hold a string, well, a reference to a string, that's the name, and also has space to have an int for the tuition bill. But I don't have the rights to just go and, this class is not part of the person class. So I can't go and do things that are private over here. If there was a private method, I couldn't access it from student. And if there was a private instance variable, I can't just say, I'm going to change it, right? We're not breaking this idea of encapsulation just by inheriting from it. But we have access through, again, this way of constructing the person part. Now, if I wanted to, there's a new access modifier. So we've looked at public, and basically when things are public, any code anywhere can get to that public thing. Sometimes, again, you have to do it through a class name sometimes, or you have to import it, but you have the right to get to it somehow. Private only means that code in the class itself can get to it. Not code in the package, not some subclass, not basically the rest of the world. There's a new access modifier called protected, and protected is designed to work with inheritance type stuff. So in protected, the class itself can look at it. So if person had a protected name, then person could still look at it. Code in the package itself can get to it, which seems a little funny, but basically you're saying if you're in the package, you probably need to be connected to each other somehow. And then subclasses can get to it. So subclasses even in other packages is the thing. But here, if I'd made this protected, I could access it directly in the student class. I could have, I could print out the name or something here. There's another one that actually I only run into because I'm forgetful sometimes. And if they have no modifier, in other words, I forget to say public or private or protected, then it has rights in the package. And to be honest, I don't really know what that's supposed to do for you. Why have no modifier? You should be, it's almost always a typo, I think. And so it's sort of bad that it lets you do anything. I think they should just make it an error. But I am not designing Java, so I can't change it. Okay, now we've made this constructor for student. And again, there's sort of two parts. This has to be the first line, if I remember, of the constructor, this call to super. At least that's true in, let's see. True in Python, I think. Let's see. Here's going to complain and say, okay, that's good. Constructor call must be the first statement in a constructor. Okay. So the form of a constructor of a subclass is you're passing in whatever information is needed to build up a valid instance of that class. And here, in this case, a student has both a name and a bill. We call the constructor on the superclass through this super keyword, and we pass along the information that's needed to construct it. This is not some random thing. Here, the person class has a single parameter, and so our super call has a single argument. They have to match up. And then I assign other stuff as needed. All right. Now here it's complaining because I need information. My bill is $10,000. All right, so if I run it now, it built it. I don't use it, so it's a little, I can't tell what's going on here. So I want to see what actually happened when I when I do this. Now, notice U has access to the change name method. Where does this come from? Well, when I inherit from person, I inherit the storage for the instance variables, and I inherit the methods. And so in this case, I can call change name directly from a student object through this inheritance process, right? So if a student is a kind of person, then an instance of student is a kind of person and has its methods, the public methods, change name. And so, again, I can run that and it should work. Now, and again, if those were protected, I could get access to them as well. Now, if I were to, let's print it out. Sys out. If I were to print out U here, where does this come from? Well, println tries to call U dot toString to figure out how to represent U as text. There is no toString in student, but we do inherit the toString from person, and so it used the toString here to represent both the student as its text. But we want to change this, and so we want a student to show more. I want to show the tuition bill as well. So we're going to make a public toString. Has to return a string from toString. And now here's the thing. What am I going to return? I can get access to the tuition bill here. Tuition bill. That's part of student. Let's see what this does first. Okay, now when I call println on U, it calls the toString here and uses this. And I'm going to say that, okay, so there's a conflict here. So far, person has a toString. We inherited that. We could use it. Student has a toString. And they're the same name and the same parameters, right? No parameters. And so there's a conflict here. Like you think that sort of like, we cannot normally have two methods called the same thing in a class that have the same parameters. But in inheritance, there's this process called overriding. And basically, if you have the same name, the same return type, and the same parameters, then this overrides the superclass method. In other words, it provides a new, more specialized version of it for use in the student class. And so when U calls toString, it first looks in its own class to decide whether it's there, and if it is, it uses it. If not, it looks in that person class that is hanging around inside it, and if there's a public toString in there, it uses that one instead. All right? So there's not a conflict. It's more like scope with variable names and stuff. It looks sort of in the class first, and then it looks at what else it inherits from and tries to find the next one it can find. Now there's a notation that you can use, override. And so for example, I don't know, let's say I had made a typo here. It's going to say the method toString exception must override a supertype method. In other words, it's saying, hey, I think you meant to modify the one that's available from the superclass, but you're not matching up with anything there. And so there's some kind of issue here. When I match up, it doesn't complain. So this is sort of just a helper thing when you're writing code that you're saying, hey, my intent here is to take the thing I inherit from person, but give it a new, more specialized behavior by redoing it in this class. And the override then checks to say like, hey, are you really changing something that's in the superclass? And if not, you're doing something wrong, and so you should go back and check. So this is good to have on these things that you're overriding. Okay, so if I run it here, still student 10,000. Now the problem is I've lost the name part, and in fact I cannot get to name. Name is, again, a private instance variable person, and I cannot directly get to it. If there was a get name, I could use that public get name and get the name out that way, but I don't have that. And instead, I'm going to access it, the toString that I inherit, but I want to disambiguate it. I don't want to use this toString. I want to use, let's say I want to use the toString from the person class, and because that has that name part in it. Let's see, where should name go? I needed like a space here. And then I'm just going to go, well, I don't know what I'm doing now. So I can't say, if I say toString here, trying to get to the parent class, this is just going to call itself, which is not a good thing. Instead, you know how like we have like the this we can use to say this belongs to the current class or the current object? I can use super here to say call the toString on the person part of me, the part I inherit from. Okay, so let's just see what this does first. And then, okay, so student tuition bill plus whatever comes out of the toString from the person part, name Sally. And this, again, what does this refer to? It refers to the current object, but the part of it that is inherited from. So it's the person part of the U object. This refers to the U object, right? Super refers to the superclass part of the U object, person part. So super toString says, hey, go to the person part and call that toString. I can call change name, directly. Ugh, don't do that here. So I can say change name here to Bill. And because there's no change name in the student class, I don't have to say which one it is, whether it's from the person part or the student part, right? The only one that exists is in the person part, and so we can find that. Here, with a toString, there are two versions, with a student one overriding the person one. So if I recall toString, I have to know whether I mean this toString in the student class or the toString that is in the person class. And to get to that person class one, I use this super dot notation to get to it. Okay? So again, I'm building on stuff. I didn't want to rewrite, I didn't want to make everything in the person protected or public, because then these two classes are intertwined a lot. Why make them two different classes if one has access to the other, right? Instead, I'm going to build on it by saying, hey, here's my toString, has this specialized information, and then just use the part that belongs to person as it is, and have it print itself out like that. So again, I'm incorporating it. I'm not trying to redo it. I'm trying to add to it. And there's this, again, this related but not the same notation of this is the constructor call to the superclass. And this is sort of like this, but it's super, meaning the part inside this object that is the inherited part. Okay, so I made a student object, and again, that constructor called both the constructor for person and had its own code. And then I called a method that belongs to the superclass. and then I use the toString that I overrode here in the student class. But that override also used and built on the part from the person class. So it's a little complicated. Now I will say also that when you make a class, even though I extend person here, all classes also basically inherit from object, even if you don't say it. And all classes have a toString and equals method inherited from object. And again, all they do is print out the reference and compare references, and we can override them in our own methods. We'll talk about the dot equals method now. We had to wait till this inheritance one to talk about how to write a dot equals for a class. You can test if an object is a kind of a class with this instance of keyword. So if I make a student, then a student is an instance of person, but it's also an instance of, a student is an instance of student, and S is also an instance of person. It's both kinds. So we're using inheritance to show classes are related. It has the advantage of, you get something for it for free, right? You get all those methods that are public, and you get storage for those inherited instance variables. And all you sometimes have to do is just tack on like one new method or something like that extends the capabilities a little bit. It's not really just about avoiding code duplication, because you could also just use composition to get the power of the other class inside your class. You're really showing relationships between classes and saying these are part of some kind of family of classes that are designed to work in a certain way. And we will see how that works a little more when we get to the fourth part of object-oriented programming, polymorphism, which allows sort of collections of classes to sort of work together or work in the same way. So I will say the syntax is not too bad in inheritance. Essentially, it just extends. There's going to be a little funny business in your constructor to get the part that you inherit from built up properly. And then you either just use public methods directly from the inherited class, or if there's an override and a conflict, you use this super notation to show whether you want the current one or whether you want the one that's inherited from. Let me also point out, it's easy to get confused between override, which is an inheritance thing, same name and everything, versus overload. An overload is in the same class when you have a method of the same name with different parameters, right? So we've had constructors, for example, that have different values, different parameters coming in. And in the dynamic array class, we had add, which had just the value to be added on the end, or the overloaded method was with an index and the value to be added. And so those two have the same name, different parameters. That's an overload. When it's the same name and one's in the parent class and one's in the child class, that's an override. All right, and you got to get those two straight because they show up a lot. Overload, same class, different names, or different parameters. Override, same everything, but different levels of the hierarchy. All right, so we'll be using this quite a bit. This is just sort of a quick introduction. But the hard part of this is seeing sort of how it's useful. And we'll be doing that in the context of writing user interface type stuff where this is used heavily. Okay. Have a good day.